Hello everyone, this is Avnash from University of Technology Sydney and I am presenting one of our late-breaking work which is a technique to improve spatial navigation learning. We call it Virtual Global Landmark. Navigation is one of the important things for human being and actually for every living being, which involve active exploration of the environment, learning from the cues in that active exploration like a trees, building, a house, shop. And of course, once you know first two things, you are able to freely and efficiently can move in that known spaces you already explored, right? In current technology, it's very easy to move around in unknown spaces using our commercially available maps like a Google map. But the result of using these apps, these digital map, that we were not able to learn anything from the environment. Therefore, we have poor spatial learning. So the question is that how we can improve the spatial navigation skill for the user. To solve this problem, we come up with a solution. For example, we need to navigate from this starting position here, shown in the red flag, to this destination. What way we have? We have two ways. We just follow the map, using the directional arrow, reach the destination. That's what we're doing now. Another way is that, which is a bit traditional, we follow certain cues we each aware about in this environment. If we do, in my case or in this case, it's this building. Let's say I'm aware about this building. I can just follow this building as a reference point to reach the destination. But the problem in current city design and current environment that you are not able to see this building all the time. There could be several other buildings in between, trees, maybe tunnel, which block your view to see that building number one. We come up with a solution that why not we use the HoloLens or augmented reality to show a replica of building one as building three. It is always orient in the direction of building one. So in case of building 1 is blocked by building 2, you are still able to see the building 1 in replica format using augmented reality. We call this solution a virtual global landmark. Well, we come with a solution, which is a kind of old but still using technology to perform. Now we want to see if it's really useful, really effective. So we performed an. In this experiment, we asked the participant to move around in these four predefined paths using Microsoft HoloLens in the real-world environment. We asked 5 participants to do that. We have 4 randomized trials. There were 2 different conditions, which I'm going to show in the following slide. And in the end, we asked the participant to answer certain questionnaire and also do the map drawing. This is the condition 1 where user is able to see a directional arrows on the street to reach the destination, very similar to what a navigational app or commercial navigational app like Google Map or Bing Map does. User is also able to see a map visible route as a reference, but that's just part of experiment. In the condition 2, he don't see the arrow, but he always see a oriented virtual global landmark in the direction of the destination. The result, what results suggest about the VGL? We asked the participant to answer NASA TLS questionnaire in the end of each trial. We compared them between VGL and directional arrow. Like you can see, VGL always possesses less mental workload compared to the directional arrow, which is in the favor. We also look at the independent component of NASA TLS score, which again suggests that VGL required less mental processing, less performance and cognitive load, and less effort compared to directional arrow, which again is in the favor. However, VGL required little more physical effort and sometimes frustration also there among the participants. We also look at the learning effect by asking participant to draw a map in the end of each trial. We counted number of turns they walk through and number of landmarks they are able to remember. Number of turns pretty much equal because our trial was too short, but number of landmarks are significantly higher for VGL compared to directional arrow, which is a clear sign that users are better learning about environment while using VGL compared to directional arrow. And the last, we also ask their preference, their feedback on VGL and arrow. Of course, in terms of efficiency, directional arrow are better as per the participant, but in terms of learning, they think that VGL is much better to learn about the environment. So in summary, we propose a novel virtual global landmark technique for augmented reality. This technique in the pilot study very clearly show there's an improvement in spatial learning when user or participant use VGL compared to traditional map-based directional arrow. And interestingly, we do not find any additional mental workload in case of VGL compared to directional arrow. And we hope to continue perform this work in future by adding physiological measure as well.